Good morning once again and welcome to the JKMRC Friday Seminar Series. On behalf of the University of Queensland and the Sustainable Minerals Institute, we would like to acknowledge the Turrbal and Jagera people as the traditional owners and custodians of the land on which we meet today. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connection to country, and we recognise their valuable contributions to Australian and global society. Today we're returning to a discussion around ESG issues in the mining sector. Specifically, we'll be looking at a novel approach to conducting impact assessments of projects with complex, overlapping social, environmental and technical challenges. Presenting on this topic today, it's my great pleasure to introduce Dr. Cameron Huddlestone-Holmes. Cameron is a Principal Research Scientist at CSIRO, in CSIRO Energy, whose work is focused on the intersection of environmental, geological and geotechnical problems in the coal, unconventional gas and geothermal sectors. He's currently working primarily within the Gas Industry Social Environmental Research Alliance, or CSIRO, on topics relating to onshore gas production. His presentation today is entitled Dealing with Complexity in Environmental Impact Assessments. Please join me in welcoming Dr. Cameron Huddlestone-Holmes.
Thank you very much. I'd like to also add my acknowledgement to the Turrbal and Jagera people and the traditional owners of the land which we meet today, and pay my respects to their elders past, present, future. And on that topic, this year is the 200th anniversary of John Oxley sailing up what we now call the Brisbane River. I learned a lot about this history from this book. I'm not sure entirely how accurate its recount is, but I know that it has had a lot of research, and it was a very eye-opening thing for me to see how people might have been living in this region more than 200 years ago, and what it might point to in terms of sustainability of our society. So today I'm going to talk about some work that we've done looking at large-scale environmental impact assessments and dealing with the complexity in doing those sorts of environmental assessments. When we're looking in resource development, and particularly in terms of mineral resources gets, or when I say mineral, I include that fossil fuels in that as well. They're quite complex issues and they get quite a lot of scrutiny now. And so I think it's a heightened requirement for us to be able to do these assessments thoroughly, accurately, and in a very transparent way. And the sort of things that people worry about surprise you. So this is one of my colleagues fishing for Steiger fauna in the Beetaloo Basin. So I thought I'd start off by just, what does sustainable mean? So that's a sort of fairly standard dictionary definition. So it's something you can just keep continuing at a certain rate or level. So doing it the same all the time. And another probably more useful definition is what sustainability means in terms of development, and it's how what we do now might have impacts on what people want to do in the future and limiting those impacts. And that sort of leads into another concept that's commonly used in environmental assessments around the concept of ALAR. So as low as reasonably practical or practical. So that's where we're looking at whether development that we're doing is going to have the impacts are mitigated to a level that we are happy are as low as they can be. Now, of course, this is, as well as thinking about what's sustainable, we have to look at what challenges are facing society, and a big driver on the world at the moment is the need to move from a carbon-intensive economy to a lower emissions economy. And I watched a presentation from this series that was from last year that sort of put a bit of emphasis on the amount of resources that are going to be needed to facilitate a transition away from renewables. To renewables, sorry. Professor Michau's talk was very interesting, looking at what that demand might look like. And it'll be very interesting to see how society addresses that challenge in terms of alternative sources of metals and minerals or materials that drive that transition. And it's not just the mineral resources that will be important. There are other resources in the environment that we use. So we're going to need land for renewables. So the image on the left is a mock-up from Sun Cable and their proposal to put I think between 10 and 18 gigawatts, depending on the point in time you look at their proposals, of solar panels in the Northern Territory. So it's about 120 square kilometres of complete coverage of solar panels. That same area has cattle, and cattle are obviously an important food source for many people. And that is also the same area that we were looking at in terms of shale gas resources. So you have those intersecting demands all overlapping. So, and when you look at this development and developing sustainably, the natural environment is under increasing pressure from the cumulative impacts of human activity. So it's not just a mine, it's not just a gas development or a cattle property or a solar farm, it's the intersection of all those things together, as well as the ecosystem services they provide. So we are going to need to keep developing these natural resources to maintain the lifestyle that we all enjoy. So we all have an impact on the use of those resources because we all buy and use the things that we use. And there is an increasing understanding and scrutiny over these impacts. So the size and scale of environmental impact assessment is increasing all the time, not because the environment's getting more complex, it's because our understanding is getting more complex of that environment. And then the level of scrutiny is also increasing. So how do we assess these impacts and allow sustainable development? And there's another aspect of sustainable that I think is a useful concept in terms of definitions of the word. You know, can I sustain my argument? That sort of definition. So when we're doing our environmental impact assessments, can we do it in a way that they can be upheld and defended to the public? And so in the Northern Territory and some other jurisdictions, they have the concept of ALAR and acceptable. So the acceptable criteria is an interesting one because it's acceptable to who, under what set of criteria. But it just really highlights the fact that it's not a straightforward and simple, you know, can we mitigate the impacts? It's because there will always be impacts. It's can we do it in a way that's acceptable to society? So the primary sort of instrument for assessing impacts of a big development, environmental impact statements. So, you know, they are done all the time. And here's an example from a coal seam gas project in Queensland. So this is about half of the documents that go into the environmental impact statement for one of these developments. So I think there's 70 on the screen there. So there's a whole lot more. You can download all those PDFs and read them at your leisure. So it's a great wealth of information and all in discrete individual components. So that's tricky to get your head around. For any one individual to be across and know and understand all that would be very, very difficult. So it's a real challenge. So how do we address these cumulative impacts? How do we make the information accessible? And is that accessible? How do we deal with spatial information? So in a report like that, it's like an EIS, like when I showed you, it's all A4, you know, the mapping and stuff is somewhat limited. And how do we do dynamic analysis? So this is the EIS as completed in 2010, still on the company's website. That is the statement. They have other environmental management plans internally, but we don't see those in the public. So this is more showing that's a point in time. So how do we make that dynamic so we can see how things are changing or improving or whether those mitigations are actually working? So there's an emerging trend around digital assessment. So the Australian government's got its digital environmental assessments program and they're engaging with the states around how to implement that. The West Australian Environmental Protection Agency established a working group that WOBSE and WAMSE, which are institutes that do research around environmental impacts and things like that, onshore and offshore. They did some work on looking at a roadmap for moving that direction. It's largely been focused around data collection and sharing in the first instance, but then they're looking at what might happen next in terms of a workflow into getting actual assessment and analysis. And there was a talk here last year from Dr. Seligman around optimizing mine closure with causal network topology analysis, which overlaps a bit with what I'm going to talk about today. Okay, so the work I'm going to present is largely focused around a big project that we had in CSIRO with collaborators in geometeorology, geoscience Australia, and others, to look at potential impacts of onshore gas developments. So this was a big program, so $35 million. It looked at 3 regions, had a very large team of scientists, and a very large area to cover. So the goal was to provide that independent scientific assessment to assist decision makers, a very comprehensive knowledge base with data and tools for regulators and others to work on. We considered the current regulatory framework because that's part of the controls over impacts, and considered monitoring strategies going forward. The program ran over 4 years and had 3 stages. The first stage was to identify where we're going to work. It sort of scoped things out. The second stage was characterizing the regions that we selected in detail about the geology, the environment, water resources, those sorts of things. And then the stage 3 was where we actually did the impact assessment work. So the areas that we focused on in the end were the Cooper Basin in Queensland in South Australia, and the Bigley sub-basin in the Northern Territory, which I'll just refer to as the Bigley Region from now on. We also were looking at the Isa Super Basin, but because there was very limited prospect of development anytime soon and difficulty in access, we decided not to proceed with an assessment on that one. And so we just focused on these 2 areas. So I'm going to focus on the risk assessment component. We needed to develop a method that would work for an assessment of this nature. So we needed something that we could do an assessment where the activities, we only had general knowledge of because it weren't assessing a particular development. Certainly for the Beetaloo, we have no idea what a development at scale may look like there, if it will happen at all. So we know the region that these assessments were done in, but we don't know exactly where in that region development would happen. We knew a reasonable amount about the environmental values, but both of these areas didn't have a lot of data, a lot of study, particularly for the Beetaloo. And we were doing this by a diverse range of scientists with a diverse range of backgrounds and disciplines. And they're only human. So we all bring our biases, we all bring our, a priori sort of thoughts about things. So regardless of how well you work as a scientist in your own space, there is always that challenge of how do you do something like this where there's a lot of uncertainty. So it brings a requirement for a lot of expert judgment. And how do you make sure you do that in a way that's robust and doesn't allow for bias and things like that to creep in? So they're all the things that we were thinking, how do we actually achieve that? So we developed an approach through the projects. So it's not entirely unique. It's based on that sort of causal network approach. But the idea was to try to make it a system that we could look at those collective impacts of a range of activities associated with developments and see how those things interact. We wanted it to be multidisciplinary. We wanted it to be really transparent and accessible. And we wanted to make sure it was very internally consistent with the way that we were doing our assessment. We really wanted it to be spatial, so it had to explore those spatial concepts, and it had to be user-friendly. So we developed these spatial causal networks, and the basic workflow in doing that work or doing an assessment using these was to set the context. So where are we working? What's the driver? What's the initiator of activity and disturbance? Then we established a conceptual model. So we said, what is this thing? What is the activity? What's the environment? What's the interaction? Then we created the causal network. So this is an example. I think this is the Cooper Basin one here. And then we go through and evaluate the causal network and interpret the results, including things like developing monitoring plans and the like. So I'm going to go through the example of the Bigley region. So I was the lead for that region in this project, in the GBA program overall. So, the Bigley region is quite topical at the moment. It's just last week, the NT government announced that they'd finished implementing the recommendations of the Pepper inquiry. So that now allows operators to go that next step and start applying for production licenses and go through that regulatory process to get to actual production. So it's an unusual shale gas resource in that it's Proterozoic, so quite old. There's only about 25 wells in it at the moment, and the targets are shale and tight gas liquids, but predominantly shale gas. No existing petroleum resource developments in that region, and there's limited infrastructure with the exception of a north-south pipeline that runs through here, and the pipeline that goes out off to the McArthur River mine. There's around about 28,000 square kilometres and a single regulator to work with. So that's the area that we looked at, and so this is the geologically defined Bigley Basin, these two parts here. They were defined by the Northern Territory Geological Survey as the point at which the Kyola Formation reaches 400 metres below the surface. So very sort of strict geological definition of those. And we had a buffer around it that we looked at to make sure we included sort of edge effects and things like that. So the environment there, it's a tableland. It's fairly uniform in the environment. Although our understanding has improved greatly through the strategic regional environmental and baseline assessments the Northern Territory government have just completed. The predominant land use is grazing, and most of it has native title claims awarded across the whole region. So that just shows the landscape mapping classes. You see it's fairly uniform. Water resources, there's very little surface water. There's practically no perennial surface water except for a few small water holes and things like that. So most of it's ephemeral. The shallow aquifers are an important resource. So there's a Cameron aquifer, the Cameron limestone aquifer. The water table's typically 40 to 80 metres deep. So that's used by the pastoralists and towns for their drinking supply. There's some shallower perched aquifers above that. So those groundwater resources are very important to the community, and the interaction of the industry with those surface water and shallow water features is heavily regulated. So there's no laws have been implemented to say that people can't discharge wastewater to water features in the Bigley, and they can't take water from those. And the licensing of water access to the Cambrian limestone aquifers is going to be tightly regulated. They're going through those allocation plans and things at the moment. Because this was a Commonwealth funded project, our focus was on matters of national significance. So the protected matters that we were looked at, we did a search and found these 6 species of fauna. So the greater bilby, Gulf snapping turtle. Now I should have remembered these before I came. Grey falcon, crested shrike, the Gouldian finch, that little critter. I am a geologist. We had to look at what all those activities might be. So in that region for resource development as part of that conceptual model. So, and it's really interesting because when you're looking at a development like this, gas development is not a linear thing. It's not, it comes in stages. You'll have your exploration, appraisal, and then development. In our shale gas development, you'd have drilling happening fairly continuously to backfill as decline happens and things like that. So it's interesting to try to do this as a single point, but that's something we'd like to improve on in the future. But so then we developed a conceptual model of how the industry would then interact with the environment, and from that we were able to then go the next step and build our conceptual, our causal network. So this is the causal network for this the Bigley region with gas development as a driver. So there were 62 nodes in the network with 197 links. So that makes 2,078 pathways from resource development to endpoints here in blue, and I'll explain what those things are a little bit more in a second, to evaluate. So that's 2,078 different pathways by which you could have an impact. And we did that for this area of 28,000 square kilometres for the actual resource and 80,000 for that broader area. So in that causal network, it's made up of different types of nodes. So we start on the very left with the driver, resource development. So that's just saying what is the broad activity, what are its key features. So it's going to involve drilling wells and having pipelines and all that kind of stuff. So it sets that out. So then we read here the activities, and that's a more detailed step of describing those individual activities that are involved in developing a gas resource. So drilling, hydraulic fracturing, civil works for clearing, transport of material in and out, access to water, disposal of waste, which is this node here, waste and wastewater management. Then we've got the green nodes, which are the stresses. So that's what do these activities do to the surroundings? How do they interact? What do the stress they place on the environment? So that could range from removal of vegetation for land clearing, it's extraction of water, it may be release of water to the environment, which may be contaminated. So it's thought that it's maybe bringing in invasive species of plants or animals. So they're the stresses and how these activities can then have an impact on the environment or processes in the environment. That's the yellow nodes. The yellow nodes are the natural processes. So overland flow, aquifer recharge, habitat condition type things. So they're the actual natural processes, and then the endpoints on the right, these blue things are the things that we've identified that we care about. So they could be those specific species, so like a particular species of plant or animal, or it could be an aquifer, it could be a manatee, those sorts of things. So they're the endpoints that we're assessing those impacts on. For each of those nodes, there's a detailed description of the node and all its features. It includes a map to show where that might, the spatial distribution of that particular aspect and where it might be important. It's all references are here. So that's all the information is here, and you can explore it in the path or direction that you would like, rather than have to read through sort of stacks of PDFs. So to evaluate the impacts in that network, we follow this flow, and this is part of what brought us that rigor to make sure we were doing things in a fairly consistent way. So for each of these nodes, we have that description. Then between each of those nodes, we have a link. So each of those links was evaluated individually. So how does the driver cause that activity? What's that causal relationship there? How does that activity affect that stressor, or this activity affect those two stressors? So we looked at those and evaluated those individual nodes using a very consistent framework. So what we started off is just asking the question, is it actually possible? So there may be things that just can't happen because the law doesn't let you, or because it just would not be necessary in that area for the development you're looking at, or there's no way that link could happen. Then we go to the next step and say, if it's possible, is it material? So because we couldn't go to the depth of likelihood and consequence in detail, like you would with a risk assessment where you actually know more about the activities, we had to try to pick something that would allow us to do something similar. And that's what we used material impact for. So is it something that actually would matter? If it was material, could it be avoided? We had a fairly strict definition there, and that avoidance was basically sort of through regulations. So for example, for drilling, you couldn't drill in a national park, right? So that's against the law. So if drilling would have a material impact, it's not allowed in that area. So we could then, say that wouldn't happen in those regions. And then if it's possible, if it's material and it can't be avoided, can it be mitigated? So can those impacts be reduced somehow through regulation or operational aspects? So that's how we did each individual link. And that was all done independently through a very rigorous structure and way of assessing that. So that allowed like an ecologist or a groundwater person to assess their link using a very similar framework. And so then we could put all those links together and then assess the pathway. And then we were looking for a pathway that's complete. So if the pathway is broken somewhere along the way because there's a step that can't happen or it's mitigated, then that pathway is no longer of concern. So you're looking for pathways that go all the way through. So here's an example. So this pathway here, we're going through assessing each one of those individual links. So this one's got a link here that's possible material unavoidable cannot be mitigated. So the driver causes the activity. You can't stop that. Otherwise you wouldn't be doing it at all. Then you have a break somewhere here where that is possible but not material, can't happen. This one down here has got all purple. So these, so then that pathway will be evaluated as being of concern in some way. So that's how the whole network works and comes together. So as I said, each of those nodes has that description of that link. We have information about our confidence in our assessment. So some things we just don't know the science, we don't know about the region. So we rate our confidence in each of those. We have that description where we write out and justify our evaluation. And then we have spatial aspect here. So this is resource development increasing drilling activity. So it would only happen where there's a resource. It would not happen in the Bullbody Conservation Area because that's a national park. There are rules about doing things in waterways in the Northern Territory, so it couldn't happen there. So that gives you that spatial element for that link. You can put all those links together spatially, and so going along a path, you can see along that path where you may have impact spatially and evaluate each of those individual links spatially. So through those pathways, you can see that A to J would be green. That's up the top there, some A to J there, because there's that sort of breaks that link. But if you came down through this pathway here, you'd have this area in the corner. So C to L as that area there that we have impact. So that's how we could do the spatial assessment as well. Here's an example. It looks a bit scary, but this is how everything can then lead to having an impact on the Gouldian finch. So it ends up being a potential concern across the whole area because there are pathways that have that level spatially across the whole area. And when you look at that in detail, the main thing is invasive carnivores, so cats and the like. So they can, by having activity, they could go anywhere. So they could go into the conservation area. So your drilling and transport material could bring in cats or facilitate their existence in the environment. And that means along that whole pathway, they can have an impact. Whereas there are other pathways for vegetation removal where we're not going to remove vegetation in Lake Woods or in that conservation park or some Aboriginal lands up here. So that pathway of vegetation removal wouldn't have an impact on Gouldian finch in those areas. So that's where that spatial assessment aspect comes in. So when you look at how all that fits together with the activities that we defined, And I think this is something we did a lot of work trying to think about how do you present all this complexity. So we identified these 9 activities, and these are our endpoints that we were concerned about, and looking at all the different pathways, what would be the impacts. So so these squares, they represent the level of concern of the pathways and the endpoint area, or the percentage of the endpoint area that might be impacted. So for these little squares means there's only small portions that may be impacting the bigger squares, say the whole region. So that civil construction and the Julian Finch, it's a big square because the civil construction can lead to invasive species, carnivores, impacts their whole area. Whereas things like extraction of water and impacts on confined aquifers and things like that, the water take is so small relative to the resource, there's only a few very discrete areas where there may be an impact, and it's of low concern. So we can do this, we've done this for the whole pattern or the network. So we've got our activities, so I've just flipped that over on its side. We've got the activities, we've got the stresses and the processes. So you can see quite quickly where and how this development may have an impact. Most of the impacts are at the surface, potential impact, should I say, around protected matters, and how their habitat may be impacted through change. We didn't find many pathways through water. There's not a lot of surface water to impact, and the footprint is quite small. The volume of water is quite small. The regulations around integrity of both surface infrastructure and subsurface infrastructure are very strict. So as long as all those are applied, which I'll say here again. So we're not saying there won't be impacts. There will always be impacts. And for all those endpoints there that we have assessed, there is potential for impact. However, we found that these impacts can be mitigated by the existing controls that are in place. There were no pathways of high potential concern. So everything was mitigated to a level that would prevent anything that we would call high, that was like an unavoidable large level of change. The surface impacts were the ones that we saw had the most pathways of concern. And as I said, not much for water. And something that is really clear is that this assessment only kind of stands as long as those mitigations are implemented. So that requires the industry to comply, the regulator to enforce, and for there to be ongoing monitoring of the effectiveness of those controls. That's a very important component of our assessment, because we're not doing it unmitigated. We're implying that those mitigations are in place, so it's important that that is remembered as part of this. So, could we apply this to other technologies? So why not? So this is the Bigley solar park in India. So it's 2.2 gigawatts covering 6,000 hectares. So you can see a very large area of solar panel installation. This is from Sun Cable's EIS. So this is to the southwest of our study area. Slate Woods, a large internationally significant wetland, and this is the proposed areas of the solar farm that they would be looking at developing. So potential habitat for bilbies, migratory species using lake woods, all of that kind of thing. So it would, as we probably all know, Sun Cable has hit a bit of a road bump at the moment, but we will. It is an area that would be of interest for us to be able to take this in. And so, as well as applying to other technologies, the next step would be actually to try to implement it in a more cumulative impact kind of way. So we were looking at a single driver, which was gas resource development. So the next step would be to have multiple activities that are using the same area. Like you could use it something like one of the Ibera bioregions or something like that. So you could define it that way in like a strategic assessment. So you could have, large scale solar, grazing, gas industry, all as drivers in the one area. There'll be individual activities, so drilling would be fairly unique to gas development, but transport of material, clearing, those activities would be common across different drivers. The stresses then that those things put on the environment will also start to converge, the way that they actually have an impact. The processes at in the environment are the processes in the environment, so they don't really change depending on the activity, but they're there. And then to make it so that it all comes together, we would have to try to bring a common framework around the way that we look at the endpoints. So this is from the Northern Territory EPA's assessment criteria. These are the environmental factors they look at when they're doing environmental assessments. They've broken up these large themes of land, water, sea, air, and people, and then have those individual factors. So in our work with the GBA, we focused on particular or specific endpoints. So we would probably want to bring it back to something more like this to make that more universal, more applicable. But in each of those, you could then, with special ecosystems, that's where you could pick out your individual species because they're dependent on that ecosystem. So they're the ways that we would look at doing that. So that's what we're looking to go with this now, is to take that into that more cumulative approach and embed it more deeply into risk assessment in general. So after the geological and bioregional assessments, there was another program called the Trusted Environmental and Geological Information Program. That did expand, that was run through Geoscience Australia, CSIRO as a collaborator, and we used a more simplified causal network for those where we started to bring in other resources. So that looked at gas resources, but it also looked at the hydrogen resources, carbon storage, those sorts of things, and trying to bring that stuff all together. That project is just wrapping up at the moment. We've done a causal network looking at the socioeconomic impacts of the green hydrogen developments. So what would be the impacts of bringing in a large scale development with land use change and the industry, and then the way people interact and value. So that was an experiment to try to take it away from that traditional sort of physical impact sort of assessment that we focused on in the GBA into some other areas. We also used it to explore decommissioned well integrity. So that really didn't have a spatial component, but that was looking at the life cycle of a well and how all those different activities you do at the start then influence the performance of the well at the end. And that was a really good way of sort of exploring those sort of aspects about for a risk assessment visually and interactively with people. So that was a very nice outcome. We're currently discussing with the NT government going back and updating the Bigley Causal Network because they've just finished the Strategic Regional Environmental and Baseline Assessment Program. So they've got a whole lot more data, so we would like to update the causal network there. But also to see how we can embed this more into the regulatory process to make it more of a dynamic system so that as we're going, we can show how well those mitigations working, how the monitoring that the industry is required to do through their environmental management processes are actually being implemented and if they're being successful. And so that the risk assessment stays alive and dynamic and recognises changes in understanding or activity through time. Just to finish off, obviously this work was built by a very large number of people. So the GBA program, this is most of the people who are involved. You can see it was a large collaborative effort. So it really did require something that could allow us to bring things all together. So that's where I'll leave it. Thank you.
Thanks very much, Cameron. Some questions. Has anyone got any questions? There you go. Thank you.
Thanks very much. That was fantastic. So one of the great things about our industry is that we do all of these absolutely fantastic things and head to a final product that we would regard as scientific and measurable risk. But then over the top of that is this other risk factor. It's almost the elephant in the room. You could say the effect on politicians, on people as to how they make the decisions.
Yes.
So what's your advice? I mean, you could apply a whole kinetic network to politicians themselves in terms of risk. But what's your feeling as to how we actually then transfer this information effectively to the political level to stop the decision being made that's basically diametrically opposed to the outcome of something like this?
Yeah, I think that's a real challenge, and it comes back to that whole concept of as low as reasonably practical and acceptable, and it's acceptable to who. So I think so there's two things, there's two aspects to that. I would say is that having trusted information available that's transparent and open and people can go and see it themselves will hopefully help to, decrease that sort of voice of discontent about the process. So a lot of work that's happened in the Northern Territory, and just recently in the CSIRO study, and Kathy Witt here at UQ did the social, cultural, and economic component of that CSIRO study, and found that there's a very high degree of distrust in industry and government from the Indigenous community in the region. So it's sort of breaking down those elements of distrust. So it means, being inclusive and reaching out and taking your time to explain and share information. So that is a really important component of the process, is providing that information. However, there's plenty of research that shows that sort of that whole information deficit model around community concern doesn't address everything. It's that procedural fairness aspect. So it's having things that are transparent and open, so that the community can see what's happening and feel included and involved and listened to in those decisions. So I think that's really important. The other thing I would say, and it's not exactly the same thing that you're asking, but it's something that I think about quite often, is that as a research scientist in my area, I know what I know, but there's a whole lot I don't know. And for policy makers who are making big decisions, they have to make those decisions based on a whole range of factors that I wouldn't possibly want to try to have to untangle and resolve. So I feel for politicians who have to make those decisions, because they have to juggle so many things. That sustainability goal statement around, what are we doing now that impacts people in the future, is a really important question. And what is the future, So my work on decommissioned well integrity, am I trying to see whether wells will have integrity 50 years, 100, 500, 1,000? But do I worry about it once Australia survived under New Guinea? I don't know. It's like, so those questions are tough to answer as scientists, because we're very focused on what we do and our certainty and things like that. And we don't often have to make policy decisions.
Now we have an online question come in, Cam. How can you be sure that you've included all the potential impacts in the spatial causal network?
We can't, and we say that in our report. So, and that's one of the reasons why we'd like to keep it dynamic, so that as others are involved, we can try to capture that. One of the ideas was to see if we could actually turn this to something a bit more like a Wikipedia type model. So we actually, under the hood, in the software that we use, we have a very structured workflow. So the author writes it, then there'll be a discipline lead who will review it. Then there's the impact lead would check that they've been consistent with other value of impact. Then the basin lead, and then we had an independent review panel. So you could build that sort of a thing in, so you could make this thing live. As I said early on, our understanding of this interaction is only increasing. And it's not because the environment's getting more complex, it's because we're knowing it better. So yeah, it's a good question. That's something that we're aware of.
I was just wondering, like, as far as the impacts go, everything's sort of, those judged more or less the same way.
Mhm.
But the potential risk at the end of, say, like impacting the fish is probably perhaps lower significance than if we got contamination of the water, which will have a really
Mhm.
high impact. And I suppose publicly, those types of things are going to sway people's minds about whether it should go ahead or not. So it's sort of like the actual potential impact on people and the environment, some way of ranking that
Yeah.
at the end.
So it's partly built into what we call material and material impacts. The material impact on the building and finch compared to the material impact on water that's used by people to drink may have a different threshold. So that it's partially captured that way. And I think it was quite important to try to do this in a way that would highlight the things that are most significant to manage, where the biggest impacts would be. So I think we've captured that to some extent, but it's certainly something that, you know, how you value and how you weight those different endpoints against each other in terms of what you manage is an important consideration. Good question.
Cameron, this is a really great presentation. So causal network analysis, which you presented here, it's a relatively new area of data science. You've mentioned the low level of trust in both government and industry from indigenous communities and communities in general. Given the novel nature of this type of analytical technique, how much trust do you think people would have when presenting this type of analysis?
So it depends where people get their trust from, or how they build trust. So yes, yes. So there's a brand that helps, and so everything we do feeds into that. So it's a really important aspect of how we operate, and we're reminded of it all the time about how we do our science and how we communicate it. But in terms of the individual research and those individual components of work, it's very tricky, because as you brightly pointed out, we've got this great thing called the GBA Explorer, and if you search GBA Explorer, you'll find it, and you can have to play with the causal network. So it's all there, it's all accessible. That was a real goal, but gee, if you don't have a computer, that's kind of useless. I think so. There are some initiatives in the Northern Territory. There's the Community Education Information Program, which is an independent thing for someone to broker science. That's being run through CSIRO at the moment. We've got activities through CSIRO with GZERA, where we go out and talk to people. That appears to be the key, is that deep engagement. And so I'm going to go into an area that I'm not super confident in here, but when we go out to the Surat Basin and talk to communities there, the blue circle opens the door, and people trust us, and they go, "You're a principal research scientist in that organisation." That has a meaning, and they don't need anything else. It gives you a level of trust. With Indigenous communities, what my understanding is, and this is where I need to do better, but my understanding is that where you have to build that relationship on an individual basis. The institutional kudos doesn't carry anywhere near as much weight as the individual relationships. And so I think in a region like the Beetaloo, where there's a lot of traditional owners still with connections to country, that's going to be what will be necessary in that region. So building that trust will be very dependent on the community that you're talking to.
So just on that point, when I was looking at the impacts of the table you had, with the potential of this, the severity of the impact. I didn't actually see that particular aspect highlighted as it's highly dependent on how well the information goes. It's about that outcome, and therefore it's a bigger play.
It is, and so having that community engagement, having them understand what's happening, what the positives and negatives are, will be really, really important. And then there are overlapping land users, so pastoral leaseholders, as well as the traditional owners. So yes, getting all those stakeholders to understand the impacts and have their voice will be really important.
It's a pretty tricky question.
Good.
I'm thinking about it because of the presentation we had from the group of Aboriginal elders a little bit earlier. Comment one of them made that really struck with me was we don't always want economic development. So my question is, how do you deal with impacts on people that are actually subjective? Because what's good for some people is a total disaster for others.
Yes. So I'll go back to my comment before about policy and the role of politicians in making those decisions. So that's where you have to take in and weigh up all those different stakeholders. And I don't know that science has all the answers. So, I mean, you could go into social science, but then I think we start to go into sort of philosophical discussions about what's good and bad and things like that. So they're very, very, very tricky, particularly in the area like the Beetaloo, where you do have a really diverse range of people who want economic opportunity and people who are frightened of what that will bring and how it will change their lifestyle. I can't offer anything in that space except to set out what we think would happen, what the level of activity might be and those sorts of things. That information then can be used by those stakeholders and policymakers to make their decisions. Yes.
About causal networks, is it possible or even useful to run these causal networks as a simulation, the Monte Carlo style simulation, with kind of just running through hundreds of thousands of potential outcomes to look for sensitivities and cascading values, that sort of thing?
Yes. So I guess the front end, the causal network, and the links between things, you could use any sort of way of analysing the links. So you could go to sort of probabilistic methods. It's one in my head, but it's escaped me. But because we looked at some of those techniques early on, but what we found, we just didn't have the statistics, the probabilities and likelihoods to be able to actually do something more sophisticated like that. But yes, that is one aspect that we'd be looking at and building that maths into the system. The other things would be, doing different scenarios. What would that network look like in the dry season versus the wet season? Changes due to climate change, exploration versus full development. Those sorts of things. Be able to do those sorts of scenarios as well. They're all things that we're exploring with the tool to see what we can get to. Yeah, for that. Yeah.
One more quick question from myself. Did this work that you've done here, was that feeding into the recent decisions made by government on the Bigley Basin, or has it been made in parallel?
So yes, I guess it's achieved one of the goals that the federal government had when they started the GBA program, was that it would provide information for those decision makers. So it's been heavily referenced by the NT government in their decision, and through things, it helped to drive the work plan for the CSIRO, the environmental baseline assessment that's just been completed. The risk assessment's been used to sort of say, how have we gone with implementing the recommendations and things like that. So yes, I think there's plenty of evidence to say that has our impact assessment had an impact.
There's no more questions from the floor, no more questions online. Everyone join me once again in thanking Cameron for coming to speak to us.
Thank you.